Hello everyone, my name is Professor Wilson Kamami and my YouTube channel is also called Professor Wilson Kamami. Here it's where we simplify mathematics together. Today we are going to look at matrices. This is our second video, matrices. In the first video we looked at my introduction to matrices, types of matrices and everything. Today we are going to look at the operations, how we add, subtract, at the same time how do we multiply matrices. Let's begin. So in this case, you realize if we are given a matrix, and you are given another matrix B, if you want to add two matrices or subtract two matrices, the matrices must be of the same order. If it is 2 by 2, you can only add with the 2 by 2. If it is 3 by 3, you can only add another matrix of 3 by 3. So that is the key point, is that if you want to add or subtract two matrices, they must be of the same order. So if I want A plus B, how do we get A plus B? It is the first element you add with the first element, the second one with the second one, the third one with the third one, the fourth that way. So that's how we add two matrices, E and M, F and O, G and P. So the corresponding values, you add them, I and R. So that's how we add two matrices. You add the corresponding value, the first one and the first one. If it is the last one and the last one, so you get the last value. So that's how we add. That's the same case with even subtracting. If you want A minus B to be the same case, you start with the first one, subtract the other one. That way, the corresponding element. But as I have said, is that when you are subtracting or adding two matrices, they must be of the same order. We explained in our first video what we mean with set being matrices being of the same order. So they must be of the same order for you to do this operation. And that's how we get the addition, how we add two matrices or subtract the same matrix. So the example is this. I can take one example. I know when it comes to addition and subtraction, we don't have problem. Most of the students don't have a problem. So I don't want to waste much time on that one. I want to put much emphasis on how do we multiply two matrices. So I'm just giving a simple example. So you have these two matrices. So if you want to add the two matrices A plus B, you, as I have told you, you take the first element, negative 3 plus negative 2 plus 3. Then the second one is 3 plus 4. 4 plus minus 1. And minus 1 plus minus 2. So in this case, you realize that you have 1, 7, 3, negative 3. That's how we add two matrices. I want to put much emphasis now on multiplication. I hope this one is just a reminder. So the more emphasis will be on multiplication. So in this case, we can start with what we call scalar multiplication. With the scalar multiplication, it's a situation where you multiply a matrix with just a scalar number, 1, negative 2. So in this case, if I had my matrix like this one, A, so let me use 2 by 3 matrix. So if I want to get 3A, it's just that I'll multiply each element with 3. So I'll have 3A, 3B, 3C, 3D. So I'm multiplying each and every element with 3. So 3F. That's how we solve scalar multiplication. you multiply with each and every element with that 3. If it was a half, you can still have half. That's where the division of a matrix comes in. I may ask you half of A. It is the same thing. You multiply half with every element to be half A, half B, half C, half D, half E, and half F. That's how we multiply matrices. We call it scalar multiplication. But now, where we always find a lot of problem now, where we are going to put much emphasis, is a situation where you are multiplying 2 matrices. So, multiplication of 2 matrices. I want you to pay attention on this one, on how we multiply 2 matrices. I will take an example. First of all, I will give you the codation. Remember, we said our matrix is row times column. So if we are having, let me say matrix 1, or let me call it A1, or matrix A, which has row 1 times columns, and I have another matrix 2, I can say row 2 and column 2. So if I want to multiply 2 matrices, it means that the number of rows in this matrix must be the same as the number of rows in this. The number of rows must be the same as the number of columns of the other matrix. And the same case with the number of columns, or the number of columns in the other matrix must be the same as the number of rows of the next matrix. Let's take an example. Let's assume I have matrix A, which has A, B, C, D. And I have matrix B, which has E, F, G, H. As you can see here, it is 2 by 2. And here it is 2 by 2. The number of rows is the same as the number of columns here. And the number of columns to this one is the same as number of rows to this one. So it means that we can be able to multiply the 2 matrices. So what do we do with this one? If you want to get AB, if you want to get the AB, it means that I'll take AB, CD, I'm multiplying with EF, GH. And I want you to pay attention is that AB, the commutative row of multiplication, the commutative row of multiplication when it comes to matrix does not form commutative row. What do I mean? Is that AB in matrix is not the same as BA. Take note of that one. AB is not the same as BA. It does not form the commutative row of multiplication. It's not like the normal numbers where you have 3 times 2, which is 6 is the same as 2 times 3. In a matrix, it's not the same. So how do you multiply this one? This is where I want you to pay attention. If you are multiplying 2 matrices, you pick the row. That's why I told you the row and column must be the same of the other matrix. Row of this one and the column. So you pick row at the first column. You will get one value. The same row will multiply the second column. You will get another value. Then you will proceed to the other row. It has to multiply the first column, the second column that way. When you are multiplying one and the other column, you get one value. What do I mean? In this case, what I mean is that I'll take this row, AB, I'll multiply with this column, EF. So again, the reason why we say it must be equal is that the first element will multiply the first element, the second will multiply the second element. So in this case, it will be AE. The first one will multiply the first one plus BG. In that case, you are getting one element. The same row must multiply now the other column. What it means that the first element must multiply the first element. So we will have AF. The second one must multiply the second one, which will have PH. The same case will apply. Now we have finished with the first row because that's where most of the students have problem. Row, column, you get one. The same row, another column, another one. So now we have done with the first row, with the first column, it has multiplied even the second column. Now we proceed the second row. The second row, row so that it can form also the second row this side. Second row and the first column, it will be CE plus DG. So the first one must multiply the first one, the second one must multiply the second one. So the same case, now we have done row, column. So it must multiply the other column. So it will be CF DH plus DH. As you can see. So this is how we multiply two matrices. Row must multiply column. And in that case, the row, the first element of that one must multiply the first one, and the second one must multiply that one. So when you add that one, you get one value. Let's take an example before we look at a situation where we have a bigger matrix. Let's take an example. I'm having 2, 3, 0, 4. I'm multiplying with negative 1, 2, 2, negative 3. How do we multiply this one? As I have told you, it's simple. Row, we are starting with the first row, but row must multiplies column. So it will be 2 times negative 1. You will have negative 2 plus 3 must multiply the second one, which will be 6. 3 times 2. Row, first column, you get one value. Now the same row, second column. 2 times 2, you will get 4. Then the second one must multiply the second one, you get minus 9. We are done with the first row because the row has multiplied all the column. In this case, they are only 2. We go to the second row now. It has to multiply again the column. So 0 times negative 1, you get 0. And 4 times 2, you get, it is 8. So the same column row must multiply now the second column, which will be 0 times 2, 0. 4 times minus 0, you get minus 12. So the answer in this case, you will get it is 4 minus 5, 8 minus 12. And that's how we multiply the two matrices. That's how we multiply two matrices. I want now we go ahead and look at how we multiply a bigger matrix. We multiply a bigger matrix so that you can see, as long as you know how we multiply it is row and column, nothing will change. It is the same strategy that we are going to use, regardless of how matrix it looks like. Let's look at another example. So in example 2, remember when we are multiplying two matrices, we said the number of row and column of the other matrix must be the same, and vice versa of the other one. So in this case, I'm going to take 2 by 3, multiplying 3 by 2. So in this case, what I'll do, I'll have a matrix A. We are multiplying a matrix that is 2 by 3. It is 2 by 3 matrix because we said the row column. The numbers of row are 2, 3 column. So in this case, we are going to multiply with 3 by 2, 3 rows. So in this case, we have 3 rows but 2 columns. How do we multiply that one? It's simple. Again, we said we start with the row. So AB, we said we will start with the row. Row must multiply a column. So the row will multiply the first column. What will we get? It is the first one and the first one, AG, plus the second one and the second one, BI, the third one and the third one, CK. So the moment row and a column finish, that's where you get one value. So the row has multiplied the first column. So the same row must multiply the second column to get our second value on the first row. So it will be AH plus B and the second one, BJ, plus CL for us to get one value. And then, since we are done with the first row multiply all columns, but first column, one value. The other column, one value. So, even though there were 3 or 4, you could have taken the row, multiply the first column, you get 1. The other one, you get that way. Now, since we are done with the 2 column, we go now to the second row. When we go to the second row, it's also going to give us the second row on this side. So, the second row will multiply the first column, which will be DG plus EI plus fk. Because I told you when you are multiplying row and column, the first element multiply the first, the second multiply the second, the third multiply the third. That's why even our row was that the row of this one must be the same as the column in the other one, so that the number we are multiplying the first one, and the second, that way it will match. So in this case, we are done the second row, the first column. Now the second column, it will be dh plus ej plus fl. So in this case, as you have seen, is that whenever you are multiplying 2 by 3 matrices and 3 by 3, we will always get 2 by 2. We always get 2 by 2. The middle one, we always take the last one. So it was 2 by 3 and 3 by 2. We are going to get 3 by 2. That's how we multiply matrices. That's how we multiply matrices. The key point is that you should know that the row multiply column to get one value. The row multiply column, you get one value. The same row multiply the other column, you get one value. In that case, remember, when you are multiplying row and column, the first one multiply the first one, the second one multiply the second one. When you add that one, you will get one value. So in that case, that's how we multiply 2 by 3 and 3 by 2. Maybe the most complex at the moment we look at is when we are multiplying 3 by 3. It is the same order. Example 3. It is the same thing. It is the same thing when you are multiplying matrices 3 by 3. I'm assuming I want to get AB. I'll just write the matrix direct. A, B, C. Then we are multiplying with another one. J, K, L, M, N, O. So in this case, it's simple. Again, if you want to get AB, it is simple. Is that we said row and column. So I'll put it here. So row, we start with the first row. It must multiply now the first column to get the first value. So it will be the first one, then the first one, AJ, BM, CP. We have gotten one value. We add everything and you get one. So it has multiplied the first column. Now we have to multiply the second column. So it will be AK, BN, plus CQ. We say the first one, the second one, the third one, the third one. That's how we multiply. Now we have to multiply the third column. You have to multiply the third column. So it will be AL, BNO, then C and R, and you add everything there, you'll get one value. So we are done with the first row. Now we have to go to the second row now. The second row must repeat, we have to repeat the same thing. The second row, but now has to multiply the first column first. So we have DJ plus EM plus FP. DJ, EM, FP. We are multiplying. Now we go to the second row to get the second number. DK plus EN plus FQ. Because we said the first one, the second one, third one. And then the last one on the second row will be DL, EO plus FR. So we are done with the second row. So second row, with the first column, it will give you the second row, first element. Second row, with the second column, it will give you the second row, second element, that way. So now the last one, we have to take the last column, row, multiply the other, all three columns. But we start with the first column. So it will be GJ plus HM plus IP. Then you take this one, multiply the second column. So it will be GK plus HM plus IQ. And the same thing, we multiply the last column to get GL plus HO plus IR plus IR. So in this case, as you can see, when you add here, you will get one value. So you will get a 3 by 3 matrix. Because we said this was 3 by 3, and this was 3 by 3 matrix. So we take the last one. So you will get a 3 by 3 matrix. So in summary, this is how the operations of matrices When it comes to addition, we said if you are to add or subtract two matrices, they must be of the same order. That is 2 by 3, 2 by 3. 3 by 3, 3 by 3. 2 by 1 and 2 by 1. Regardless of they must be of the same order. So you add the corresponding value. I showed you the first one and the first one. Second, you add like that, you get the addition or the subtraction of matrices. When it comes to scalar multiplication, where you are multiplying a matrix with a number, it's the same thing. If it is 3, you multiply each and every element with that number. The same case, even though it is a fraction, it is negative, you will multiply each number with that value if it is half. So that's how we solve that one. But the most now complex part is when we are dealing with multiplication of matrices. Multiplication of matrices is that when you are multiplying two matrices, they must be of the same order, or the number of rows in the first matrix must be the same as the number of columns in the other matrix, or the number of columns in the first matrix must be the same as the number of rows in the other matrix. I've given an example. I started by 2 by 2, and I showed you how we multiply. So we start with the first row. It must multiply all columns. But the moment you are multiplying one column, you get one value. That is how AB multiplied EG. But A must multiply E, B must multiply G. And that's how I showed how we multiply two matrices. 2 by 2, 2 by 3, we multiplied with 3 by 2. And I have shown you even how we multiply 3 by 3 matrix. This is very important for your own revision, because our next video we shall look at how we get the determinant and the inverse of 2 by 2 and 3 by 3 matrix, and use the same to solve what we call simultaneous equation of 2 unknowns and 3 unknowns. So continue watching. This is where we simplify mathematics together. Thank you.